Next MCQ, question number 25. A satellite moves in an elliptical orbit about a planet. The maximum and minimum velocities of the satellite are 3 into 10 raised to 4 meters per second and 1 into 10 raised to 3 meters per second respectively. What is the minimum distance of the satellite from the planet if the maximum distance is 4 into 10 raised to 4 kilometers? So the values are given like this. Vmax is equal to 3 into 10 raised to 4 meter per second. V minimum is equal to 1 into 10 raised to 3 meter per second. Then the maximum distance Rmax is equal to 4 into 10 raised to 4 kilometer, that is equal to 4 into 10 raised to 7 meter. R minimum is equal to question mark. By Kepler's law, by Kepler's second law, we have used this law. By Kepler's law, in an elliptical orbit, angular momentum capital L of orbiting planet is always remaining constant. Therefore, L is equal to m into v into r is equal to constant. M is equal to mass of planet. Therefore, v into r is equal to constant. Therefore, v1 r1 is equal to v2 r2. So if this is the elliptical orbit, then this is the sun. So this is the Rmax. So at this point velocity is minimum. This is the R minimum. So here the velocity is maximum. So V1 means V minimum Rmax is equal to V maximum into R minimum. So substitute the values. So minimum velocity is 1 into 10 raised to 3. Maximum distance that we have to calculate. Maximum velocity is equal to 3 into 10 raised to 4 multiplied by, Rmax is given. Rmax is equal to 4 into 10 raised to 4 and R minimum is equal to question mark. So this is the meter. First we find the answer in meter. So this 4 will get cancelled. So 4 by 3 into 10 raised to 6. So R minimum is equal to 4 by 3 into 10 raised to 6 meter is equal to 4 by 3 into 10 raised to 3 kilometer. So velocity is maximum at minimum distance from the sun is equal to 4 by 3 into 10 raised to 3. So correct answer is C. The C is correct. So angular momentum remains constant because aerial velocity remains constant. याचा एक प्रॉब्लेम आपण घेतलेला आहे. Next MCQ. Question number 26. It is a theoretical question. In an elliptical orbit under the gravitational force in general, A. The tangential velocity is constant. B. Angular velocity is constant. C. Radial velocity is constant. D. Aerial velocity is constant. So correct choice is D. So why A, B, C is wrong? The reason is this. For an elliptical orbit of a planet A, angular momentum L is equal to m into v into r is equal to constant. Therefore, v into r is equal to constant. Same law. V into r is equal to constant. Therefore, as r changes, the tangential velocity v also changes in magnitude as well as direction. Therefore, A is wrong. B. Since tangential velocity v changes, the angular velocity also changes in magnitude. Therefore, B is wrong. C. As the planet revolves in an orbit direction of radial velocity VR changes continuously. Therefore, C is wrong. म्हणजे डी करेक्ट असतात पाहिजे आणि डी हे केपलर लॉचं स्टेटमेंट आहे. डी बाय केपलर second law. The straight line joining the sun and the planet covers equal area in equal interval of time. Therefore, area swept per unit time by the line is remaining constant. Therefore, aerial velocity A by T is the remaining constant. So this is the correct choice. Therefore, D is correct. So out of 4 choices, only D is correct, and it is this second law of Kepler. Next, question number 27. If the mass m is split into the two parts m and m minus m, which are then separated by a certain distance, the ratio m upon m, which maximizes the gravitational force between the parts, is 1:4, 1:2, 4:1, 2:1. So here we have to apply the theory of maximum and minimum. So we have to maximize the ratio. So for maximum and minimum, the first order derivative must be 0 and second order derivative should be according to the condition. So by using first derivative is equal to 0, we can find the correct distance like this. So here the two masses are separated by distance r. So this is the first mass, m1 is equal to capital M. This is the second mass, m2 is equal to m minus m, and the distance between them is r. So gravitational force of attraction between m1 and m2 is F is equal to G m1 m2 upon r square is equal to g into m minus m upon r square upon r square. So you have to find the ratio small m upon capital M. Small m upon capital M is equal to question mark. So this is equal to f is equal to gm square upon r square minus gm upon r square. This is equation 1. So the force will be maximum when df by dm is equal to 0. Therefore, now you have to take the derivative of the left hand side. So d dm of m square upon r square minus gmm upon r square is equal to 0. So derivative of the first term gm square upon r square minus derivative of the second term gm upon r square is equal to 0. So this is small m. The two masses are small m and m minus m. So we check m1 is equal to m, m2 is equal to m minus m. So m1 into m2 is equal to m square like this. So this is m square, this is m square like this. And now you have to apply the rules. So this is equal to 2 times gm upon r square, derivative of the first term, minus gm upon r square is equal to 0. And therefore 2 times m minus m g upon r square is equal to 0. And then 2 times m minus m must be equal to 0. And therefore 2 times m is equal to capital M. And therefore m upon m should be equal to 1/2. The ratio should be 1/2. So both the parts should have equal mass. And therefore correct choice is B. B choice is correct. So remember this method. The total mass is m and it is divided into the two parts. The first part has mass small m, so second part has m minus m. M is the total mass. So capital M is constant, but small m is variable. Therefore, both the masses are variable. So we have to differentiate the equation for force with respect to small m. Sorry, please make the correction. This is equal to m into capital M, and this is equal to m square. So this is equal to m into m. This is equal to gm square. So m into m. This is m square. So the derivative is 2 times Gm, and this is equal to 2 times Gm. So m minus 2m is equal to 0, and the m minus 2m is equal to 0. So 2m is equal to m, answer will remain the same. So here brackets open करता ना m into m लिखे m into m square minus 0. So this is m square, this is m square. So derivative of m square is equal to 2 times m. Like this. Now it is correct. So I will read the question. A uniform ring of mass capital M and radius capital R. So make the correction here. Radius should be capital R. Radius capital R is placed directly above a uniform sphere of mass 8m and the same radius R. The center of the ring is at distance d is equal to root 3 times R from the center of the sphere. The gravitational attraction between the sphere and the ring is given by. So value is given in terms of capital G, capital M and capital R, like this. So the situation of the problem is like this. Both the body have same radii. This is the important condition. So I will draw the figure. This is a solid sphere of radius capital R, mass 8 times m. This is the center. So directly above there is a ring of mass m. It has again same radius. So this is m2, sorry, m1 is equal to capital M. Radius is equal to R, and the distance d is equal to root 3 times R. So you have to find the force of attraction between them, like this. So here first we will do the rough first. So these are the two bodies. So gravitational force F is equal to m1 into capital G upon d square. So this method is not applicable because M1 is equal to M is distributed at distance R is equal to under root d square plus r square from center of sphere. So this method M1 is equal to M2 is equal to 8 times N and D distance. This method cannot be used because this mass is distributed over the ring like this. So here we have to use another method, and that another method is the definition of electric field, gravitational field intensity like this. So gravitational field intensity E is equal to F by M. So F is equal to M into E is equal to gravitational force experienced by M in the gravitational field E. So we have to use this relation. So if we use the electric field produced by the ring, then this is given by F is equal to, it is the force experienced by M2. So F is equal to M2 multiplied by E1. This is the basic formula. This is the equation with capital E. F is equal to gravitational force experienced by M2 in the gravitational field E1 produced by M1 like this. So M2 we know, so what to find E1? E1 is equal to gravitational field intensity produced by a ring of mass M1 is equal to capital M at center of sphere of mass M2 is equal to 8 times capital M. Therefore, E1 is equal to, हा फॉर्म्युला पण डायरेक्टली ना. सिमिलर प्रूफ आपल्याला मॅग्नेटिक इफेक्ट्स ऑफ इलेक्ट्रिक करंटच्या चॅप्टरमध्ये बघायचे आपल्याला. इफ देर इज अ करंट कॅरिंग ring, then it produces the electric field, magnetic field along its axis. So that direction and magnitude of the electric or magnetic field can be determined. So using the same method, so that derivation is given in our books, board books also. So this electric intensity we will write down directly. So this E is equal to, E1 is equal to G M1 D upon this distance between them is equal to D square. So D square plus R square bracket raised to 3 by 2. So we will prove this relation afterwards. This is equation capital U. So this relation we already know. This relation is new for us to be derived. So substitute this value of E. And therefore E1 is equal to G M1 is equal to capital M into D. D is equal to root 3 times R upon D square. D square is equal to 3R square plus R square raised to 3 by 2. So this is equal to G capital M root 3R upon this is 4R square bracket raised to 3 by 2. So this is equal to root 3 G capital M upon R and this is equal to अगोदर 4R square चा रूट जर आपण घेतलं तर ते 2R होऊन जाईल 2R bracket raised to 3. So this is equal to root 3 into G into capital M upon R divided by 2R cube, that is equal to 8R cube. 8R cube. 1R will get cancelled. So gravitational field intensity E1 is equal to root 3 G M upon 8R square. So this is equation 1. So we know the value of E1. So in this equation M2 is equal to 8 times M and E1 is equal to this. So you can substitute the value. Therefore put 1 in A. Therefore gravitational force of attraction between ring and sphere is equal to M2 is equal to 8 times M multiplied by this is equal to root 3 Gm upon 8R square. 8R square. So 8 will get cancelled. So this is equal to F is equal to root 3 G M square upon R square. Equation is dimensionally correct. There is a M square in the numerator and R square in the denominator. So the correct place is B. Therefore D is correct. So why this method is not applicable? The reason is important. So we have to find the gravitational field intensity produced by ring at this point, and it is denoted by E1. So E1 is given by this formula. So remember this formula. Similar formula we are going to derive in magnetic effects of electric current. So you can get that relation. Board book. Page number 243. 243. Article number 10.13. Equation 10.53. Similar derivation. Similar derivation. So this is in the chapter magnetic effects of electric current. So you can derive that relation like this. So this is a complete different type of problem. So in this case, we have to find the gravitational force of attraction between ring and sphere. This is the first body of mass m1 is equal to m radius r. This is the second body of mass m2 is equal to 8 times m into r. This r radius is same for both the sphere. So generally we use this formula g m1 m2 upon r square. So r is the distance between the center of the two sphere. But this method is not applicable. Why not applicable? Because this mass m1 is not concentrated here, but it is distributed all over the body, and therefore we have to find the gravitational force by using this formula: mass multiplied by gravitational field intensity. So mass is this force experienced by this m2, and this intensity, gravitational field intensity, is produced by ring. So E1 is equal to gravitational field intensity produced by the ring of mass m1 is equal to m at the center of the sphere of mass m2 is equal to 8m. So this formula we have used directly, but it can be derived in the similar way as given in our board books. The article number 10.13 in magnetic effects of electric current. So equation 10.53 is similar to this, like this. So we know E1 by equation 1. By substituting the value of D, we have obtained E1. So we know E1 M2 is equal to 8 times M, and therefore by substituting we get the correct answer this much. So force of attraction between the ring and the sphere is equal to root 3 gm square upon r square. Next, 29 and 30 we will see afterward. They will take some longer time. First we will see 32. The body situated on the surface of the earth at what height in kilometer over the earth's pole? The free fall acceleration decreases by 1%. Assume that radius of the earth to be 6,400 kilometers. So we have to find h. So acceleration decreases by only 1%. Since g decreases by 1% only, therefore h is very much less than r. Therefore gh is equal to g into bracket 1 minus 2 times h by r. This is equation capital A. G is equal to g minus 1 upon 100 g, that is equal to 99 upon 100 times g. R is equal to 6,400 kilometers. H is equal to question mark. But to find the height, so substitute. So G is equal to 99 upon 100 into G is equal to G into bracket 1 minus 2 times H by R. So the G will get cancelled. So 99 upon 100 is equal to 1 minus 2 times H by R. So 2 times H by R is equal to 1 minus 99 upon 100, that is equal to 1 upon 100. Here H is equal to required height above earth surface. And that 2 times H is equal to 100 multiplied by 100. Therefore, H is equal to R upon 2 multiplied by 100. So that is equal to 6400 upon 2 multiplied by 100. So that is equal to 100 will get cancelled. Therefore, height H is equal to 32 kilometer. 32 kilometer. And therefore, the correct choice is therefore A choice is correct. Actually, there is one more formula. V is equal to G into bracket R upon R plus H bracket square for any value of H comparable or greater than R. But when H is negligibly small as compared to R, then we have to use this relation. We have to use this relation. So there is a condition. So gravitational acceleration decreases by only 1%. So there is a small change in gravitational acceleration. Therefore, height is small as compared to the radius of the Earth. And therefore, we can use this formula directly. Okay, we will stop here. Question number 29 and 30 are remaining.